Okay. Gravitation. Gravitation is a natural force. That means force created by the nature. And we have found that any two particles, material, attract each other. We have found that this attraction is more if mass of the particles are more. We have found that this is not available in radiation, in the waves. So we have made a rule that gravitation, for gravitational force, the property which is required is mass. Now, any particle, any material which has got mass is able to attract another particle which has got mass. And this force is gravitational force. Now, we increase the mass and we find the gravitational force also increases. So the cause of gravitational force is mass, and it increases with the increase of mass of the two bodies. When we change the distance between the two bodies, again there is a change in the force. If we increase the distance, the force becomes weak. And here we have seen that if the distance has become 2 times, the force weak 4 times. So if the distance increases 3 times, the force weakens 9 times. So this is known as inverse square law. If the mass, this mass is 1, this is 1. If they become 2 and 2, if they become 3 and 3, 3 and 3, 6. So the force will become how many times? Not 6 times? What is the difference between 6 and 9? The difference is 6 is m1 plus m2 and 9 is m1 multiplied by m2. And what we have observed, that gravitational force is 9. So what is the rule? m1 plus m2 or m1 into m2? Right. So that is the rule for two masses. It is proportionate to product of the two masses, and it is inversely proportionate to square of the distance. So that is gravitational force. What is this? Gravitational force is proportionate to m1, m2. Product inversely proportionate to square of the distance, and if we make it equal, we have to put one constant. This constant we cannot make 1 because we have already defined 1 kg, we have already defined 1 meter, we have already defined 1 Newton. And when we put this 1, 1, 1, 1, it does not come equal to 1. That is why G is not equal to 1. And what is the value of this constant? G is equal to how much? 6.67 into 10 to the power minus 11. 7. Okay. This. Now, what should be the units of it? Newton meter square per kg square. Okay, so this is per kg square. This is the value of G. What are its dimensions? Please tell me the dimensions. Okay, this is F into R square, that is kg. M minus 1, L3. These are the dimensions of gravitational constant. So gravitational constant is a constant which has got dimensions and which has got a magnitude, a quantity, right? And there is a unit of that. Now, it is stated, it is found that this constant exists between different planets, different stars, everywhere in the universe and its value do not change. Therefore, we say it is a universal constant. So, why it is called universal? Because its value do not change from star to star anywhere in the space in the universe. That is why it's a universal constant. Okay, now gravitational force, because it is a force, it is a vector quantity and we can very well write in the vector form just by giving the definition. This is a force of attraction. The gravitational force do not change with the medium. Please remember this. The gravitational force between water, between the glass, anywhere, it same. Which force is different? Which natural force? Electrostatic force. If there is a medium in between, the electrostatic force change. But gravitational force do not change. Gravitational force between the two bodies is not affected by presence of any third body. Gravitational force always act in a straight line. There are two types of acting. Magnetic forces, how do they act? They act perpendicular to the velocity, like that. But gravitational force act in a straight line, joining the centers of two bodies. This is a macroscopic force. That means it can act to very, very large distances. All the stars of the universe are bound by each other with the force of gravitation. So it is a long distance force. Now tell me, which are the short distance forces? Yes. Very good. Strong nuclear and weak nuclear forces are the? Yeah. Short distance forces. And any other quality of the gravitational force? I'm forgetting one thing. Yes? It is central force. It is conservative force. What is conservative force? Yes. When we calculate work done by this force, when we calculate work done by gravitational force, then path is immaterial. Initial position and final position are important. If the gravitational force is acting on this body and this body comes by a staircase here, the gravitational force acts downward. Then the work done is equal to mgh. This is the h. If this body comes from this place and go by aeroplane like this and then lands here, again, how much is the work done? Mgh. And if by lift it comes down straight like this, how much is the work done? Mgh. So whether it comes by this slide, by the projectile, by the straight line lift, in every case the work done is mgh, and which is the force here? Gravitational force. That is why we call gravitational force as conservative force. Right? So this is these are the properties of gravitational force. Now the example which we are going to apply here is gravitational force applied by the earth, because we live on earth and this is the most visible thing around it. Because of this gravitational force, what is the proof of this gravitational force? That it exists in the universe, it exists in the space. The answer is the motion of different planets and stars is the proof. How there is the proof? It is a proof because the moon is moving around Earth. If there is no gravitational force, then according to first law of Newton, the moon, which is moving, should keep moving in a straight line. So if here is the Earth and here is the moon and the moon is moving in this direction, after some time it should go here, away. But we find it does not go away and it bends towards Earth. Why it should bend towards Earth? The only reason we find there has to be some force which makes it bind, and that because of this force, it does not go straight, it goes toward the resultant. Again it wants to go here, because of this force, it goes toward the resultant. and this way it goes on making a circle. So this path around the earth, because it is not leaving earth and all the time it is turning towards earth, we say there is a force, and that was the basic thing, that why and how gravitational force was invented. So by seeing the stars around earth or stars in the space. There is a long story, but this story is not asked in the examination. Therefore, we will not give time to that. That story starts from philosophy, Aristotle's philosophy, Aristo's philosophy. After that, there were many more philosophers. Then Galileo gave it a thought, that heliocentric theory and earth-centric theory. After Galileo, many more. Kepler was quite later. Before that, Ptolemy was there. And after Ptolemy, Tycho Brahe was there. And after that, yes, after Tycho Brahe, there was Kepler. And the rules that there exists a force of gravitation was first given by Galileo. Gravitational force. Okay? The rule that the planets and the sun move around Earth, or Earth move around sun, that was also started by Galileo with help of his what? Telescope. He was the inventor of telescope. So he saw all these movements, and he was the one who tell that there exists a force. So he has this credit to find the gravitational force. Okay. After that, that study was studied by Brahe, and he made all the timings and he did all the mathematics. So much data he had that it was a room filled, more than a data kept by a supercomputer. But if somebody wants to do the calculation on the basis of that data to prove that how the planets are moving, what is the quantity of force, for that a lot of time was required. And time period, active time period of one human life is 40 years. Within that 40 years, he only collected data. He could not do the calculations, and he died. After his disciple, Kepler, took all those data, he did the calculations. So it took 3-4 generations. And Kepler calculated it, and he made Kepler's laws. With help of those Kepler's laws, whatever results were there, that was studied by his disciple Newton. And Newton wrote a book, Laws of Gravitation. So the credit, of course, nowadays we say it is Newton's law. It's not Newton's law. Gravitation was first started at the time of Galileo. And all this research in 200 years, taking 4 generations, that came to this law, what Newton made, as F is equal to G m1 m2 upon r square. So there is a long story behind it. Okay. So what we are generally asked are Kepler's laws, Newton's laws. This was the proof about it. With this force, we should also study, I think, Kepler's laws. That is in the syllabus, I suppose. So we will see Kepler's laws. You all know Kepler promulgated 3 laws. One is the law of, yes, tell me, orbit. He said that around the sun, the orbit is not circular, but the orbit is, yes, elliptical. This is one very important thing, that what is the shape of orbits? Elliptical. And in ellipse, there are so many properties we have studied. There is a major axis and there is a minor axis, and there are two focus. Okay, you know the properties of ellipse. Even if you don't know, it doesn't make much of difference as far as physics is concerned. But there are always two focus. And what he said, that planets or like Earth are moving in a elliptical path, and the sun is not here at the center. It is at one of these points known as focus. There are two focus in the ellipse. So he says it is either one of the focus. It may be here, it may be here. Right. And what is property of these focus? That if we join this, then this plus this always remain a constant for every point of the ellipse. Then this point C and this major axis A, C upon A, what is the quantity this gives us? Eccentricity of the ellipse. This ellipse is very less eccentric. This ellipse is very eccentric. Why? You see, denominator, this becomes small and this becomes large. The moment it becomes large, eccentricity increase. That is eccentricity. So these are one or two properties of the ellipse. That this A plus B is equal to not A plus B. Let us call it R1, R2. R1 plus R2 always remain a constant. That is one property. Then we have other properties also, like its x coordinate divided by this square, y coordinate divided by this square is equal to a constant, but all that is in mathematics. In physics we don't need that. Of course, Kepler's used it. So as a first law, what you will remember, this is what law of orbit, and what does it say? The orbit is not circular, it is elliptical. And where is the sun? At either of the focus, and Earth is moving around in elliptical path. That's all. Now we come to the second law. Second law tells us about the velocity. That is area. We can call it that is law of area. Law of area says when Earth is here and it moves to some distance here in the time t, then this is the area swept by this radius. Area swept by the radius. Once Earth is here, in the same time it moves from this place to this place. Time t, and now this is the area swept by it. Earlier we can say this was the area in time t. Now this is the area in time t. These two areas are equal. This is the law, Kepler's law. When it is again going from this point to this point to this point, this area will be same as this. How much time? T. So aerial velocity, area divided by time, is same wherever it is. Aerial velocity is always same. That is law of area. So how do we find out area in it? Area is base upon height. And this is, if time t, then its velocity is v, then v multiplied by t is this distance, and multiply this height, which is approximately r. So v1 into t multiplied by r1. Divided by r1. v1t upon r1. This is aerial velocity. Aerial velocity. You got it? This is area. This is distance. No, I'm mistaken. V1t is the distance multiplied by R1 height, that gives the area, and this is to be divided by time. So what is the aerial velocity? V1 R1. What is the here? The velocity changes, V2. So what is the aerial velocity here? V2 R2. And what is the aerial velocity here? V3 R3 here. V3, and this radius is R3. V3 R3. All these are what? Equal according to Kepler's law. If we multiply m with it, mass of the body which is moving, then this becomes mvr. And what is mvr? Angular momentum. So angular momentum is conserved when a planet is moving. Now, how Kepler made this law? Because he thought that angular momentum is conserved. So he made it. Now, in class 11 or in wherever theoretical questions are asked, it is sometimes asked to us on the basis of Kepler's law, prove the conservation of angular momentum. So we start the way I started. First we went for V1 R1 equal to V2 R2, V3 R3 multiplied with m. The result is angular momentum. If somebody asks us, based on the angular momentum conservation law, prove Kepler's law, then we will start. M1 V1 R1 is equal to M2 V2 R3 is equal to M3 V3 R3 according to conservation of momentum. Then cancel M. Then what do we get? V R1 V2 R2. Then we will say multiply with T and T. This will become what? Area per unit time, area per unit time, area per unit time, and all three are equal, and we will say that is Kepler's law. So both way it can be done. So remember this. In which law? Please remember how the question comes. If somebody, some examiner is interested to ask question on this, he will have to frame the question. He will say, which law tells us the relation between planet's velocity and angular momentum? Again, which law is derived on the basis of conservation of angular momentum? Kepler's second law, right? So this you should remember. Then if you have this theory in mind, you can always reply that answer. But answer is generally asked like this only. That conservation of momentum and Kepler's law, they are related to each other. And now we come to third law. The third law of Kepler's, this says there are many planets moving around Sun. All these bodies are moving around a single body, and every body when moves from here has a certain radius, and when it moves here there is a certain time of rotation. This is R2 and its time is T2. This is radius R3 and the time of rotation is T3. He says when the radius increases, the time also increases. But T is not proportionate to R. T is not proportionate to R, and there is a special relation. He derived it mathematically. We can also derive that, and that relation is what? Yes, square of the time is proportionate to cube of the radius. This is the third law. So these are Kepler's three laws, right? Kepler's first law, second, and third deals with what? It is not with one planet. It is a number of planets. If there are more than one planet, then this law is applied. This is for a single planet which is moving around it, and this is generally shape, right? So these were given by Kepler's, and with help of this, when we derive it thoroughly, this law and this law, we can find out the law which is given by Newton as m1 m2 upon r square. That was derived from here. We can also derive it, but we don't need to do that. Okay, we will solve certain question based on either this or this. Numericals are asked on the basis of this. We will do it today. And now, again, we come back to gravitation due to Earth. Gravity is the special name given to gravitational force by Earth. When it is force is by Earth, what is the name we give it? Gravity. A shortcut. Okay. So, if we say a ball falls towards Earth because of gravity. Right. Now, there is Earth. We suppose all the mass is concentrated at the center of mass. If there is another object, it is a very small object having mass m. Earth is having mass m. Let's use capital M for it. Then distance has to be taken from center to center, because we assume that this is a force which is taken from center to center. Central force. Okay. So if this distance is r, then we can say that this total distance r is equal to radius of the Earth, capital R, plus height of this object above the surface of Earth, h. So this r from this point to this point is equal to r plus h. So this is the notation we are going to use. Small r is equal to capital R plus h. Right. Now, if we want to apply force here, then this force is equal to G m of Earth multiplied by m upon r square, and I will write it directly this. Okay, so this is the force acting. This is the general rule what we have made. Now suppose this body is not in the space, it is on the surface of the Earth. If this body is on the surface of the Earth, then this distance will reduce to r, and this force now will become G, again m upon r square. Now it is on the surface of the Earth. This is the force on the body, and force on the body, if I drop any object here, it is going towards the center of the Earth because of the gravity. And when it goes towards center of the Earth, it falls this distance, it has certain acceleration. How can I calculate the force? With help of Newton's law, mass into acceleration. So what is the force acting on this body? It's mass multiplied by acceleration. So I write it here, mass into acceleration. Its mass is small m, and into acceleration, this is equal to G m upon r square. This m is cancelled from both the sides, and this acceleration with which this body is falling towards the ground is equal to G, mass of the Earth, divided by radius of the Earth square. This is acceleration due to gravity. And because there are so many accelerations amongst the bodies, but most of the time on the surface of the Earth, we are using this term. So we give it a special name because it is due to gravity. We give it a symbol of, yes, you all know what is that? Small g. So small g is equal to Gme upon r square. Please remember this. That is at the surface of Earth. So acceleration due to gravity is small g, and this is what? Capital G, that is gravitational constant. What is the difference between the two? It is small, it is large. Okay, what is the difference? Other differences? Both are entirely different quantities. This is acceleration, only acceleration with the dimension L t minus 2. This is gravitational constant. What is this? This is force. What is this? Force. Can we define force? I forgot to do that. Can you define it here? Make every other thing 1, 1, 1. If there are two masses, 1 kg, 1 kg, at a distance of 1 meter, then this G is equal to force. So this G is defined in the terms of force. This G is defined in the terms of meter per second square. Right? So this is the difference between the two. They are entirely different quantities. It changes from location to location. It never changes. Okay, so these are the difference. If there is a question of difference, you can always tell that. Okay. Now this we will always remember, value of acceleration due to gravity on the surface. There are so many ways of calculating it. We never calculate it by this one, because we can't find mass of the earth and we can't find radius to be exact. So we have our methods to measure this. Like we measure it with help of pendulum in the laboratory, the value of G's. Otherwise, you can simply drop something from your roof, calculate the time of falling, and with that apply the equation V is equal to U plus GT. You will find the value of G. That is the easiest method to find the value of G. Okay, so this is gravitation due to, acceleration due to earth. Now, this acceleration we have to study whether it, yes. If we go to a height here, does it make a difference? The answer is yes, it makes a difference. If we go inside, it makes a difference. What happens to this value on the earth? What is this value on the earth? Please tell me, all of us, we know it. This is on the earth. Where this is on the earth? Is it inside the mines or on the hill? On the surface. And what do you say the surface? Surface of Chikmagalur? Okay, the surface of earth is supposed to be sea level. It is sea level because we assume that sea level everywhere on the earth is at an equal distance from the center of the earth. That is not a plane, it is a circle. It is a sphere. But from the center of the earth, they are all equidistances. Okay, so that is surface of the earth. It is value at that. Is this value changes with air pressure? No. Does this value change with temperature? No. Because we know, according to this relation, this value will change only because of R, the distance between the two, and mass, the mass which is attracting it. Now, we will find how it will change. The changes in acceleration due to gravity. Okay. Variation. When we talk about variation, first we take variation due to height, variation due to depth, variation due to rotation, and variation due to shape. There are 4 types of variation, and that you should always remember in one line each. When we go above the surface of Earth to a considerable height, how the value of G will change? The answer, the value of G, as we know, is equal to, you have just done, please remember this formula. This we will have to apply again and again. If it is surface of Earth, then G at Earth is equal to Gm upon R of Earth square. If we are going to a height h, then it is equal to Gm upon R plus h square. And what is the ratio of the two? The ratio of the two is height divided by G is equal to this upon this. So what will be? R upon R plus h square. So which is higher? Which is larger? Denominator is larger. This is denominator. This is gravity on the surface of the earth. So this is smaller quantity. That means when we go to the height, the value of acceleration decrease. So we simply write it at height, G decrease. And this is the right formula for it. Again we derive this formula for small distances. In the small distances, we apply a binomial theorem and we draw the higher, the higher powers. And what is that result you get? Anybody remember? Yes, very good. G on the earth, 1 minus 2h upon r. There is a mathematical derivation. It is derived from here only. This G has gone here and then this is divided by r square and we get it. That is mathematics, you don't have to do it. It is not asked. But this is for what? When height is much less than r. If height is considerably large, half r, more than half r, 1 r, 2 r, 3 r, then we have to apply this. So please remember, this is the main formula which never fails. This may fail. If you apply it for a distance of 2 r, this will not help. If there is a distance of 1 r from the surface of the earth, this is surface, this is radius, and here is the body, and this is again r. So how much it becomes? 2r. Right? So if you write, or even if we go to the distance of half r, how much this will be? Half r into 2? R minus r upon r, 1, and this will become 0. But it doesn't become 0 at half r. That means this formula is not applicable for heights, larger heights. When we have to apply it, when h is very, very small compared to r, and it is reflected in mathematics that whenever we are rejecting higher powers in binomial theorem, then that means that quantity has to be very, very small. H upon r has to be very small. Anyway, so you will remember the result only, that this h upon r has to be very small quantity. Okay, this is with the height. Now suppose we go inside the earth. Then what will happen? This you will remember the formulas. Now we go inside the earth. We go so much deep in the earth. This is center of the earth. This distance is r. This was r, and this is some distance. What will you call it? D. So now how much is this distance left? R minus d. Now I draw a sphere from here. Same center, this sphere. Now one theory we have to understand is that when we draw this sphere, then this ball or this mass is attracted by only internal sphere. Not by this, not by this, not by this, not by this. So the mass which was attracting it, the whole mass which was attracting it has reduced. Mass has reduced. If the mass of Earth has reduced, what will happen? But then you will say the radius has also reduced. Then we have to see which reduction is more powerful. Can you tell me which? Both things are reducing. Mass is reducing. This r is also reducing the distance. Which reduction is more powerful? Why? Depends upon? No. There is a very simple mathematical reason. Please think. Tell me yes. Hey, you are all making things mugged up. You are not understanding. Okay, yes. Tell me the formula for mass. Density into? Tell me the formula of volume. 4 by 3 pi r? R? Cube. This has got r cube. This has got? Which is more powerful? R cube is more powerful. Understand? That is why when we decrease radius, both are decreasing, mass and radius, but which is more powerful? Which has got more power? R to the power 3. That is why the effect of mass is reduction is more. So this quantity ultimately reduce. that means G value is reduced. This is the general feeling. How much it is, that we can always find out, and you have done that, I will not do that. We will simply do what? We will find new mass of this sphere, 4 upon 3 pi r minus d cube, right? And then we will do all those calculations, etc. What we find, that acceleration due to gravity at a depth d is equal to GE, and this is 1 minus d by r. And you see, it is G minus something. That means it has again decreased or reduced. So when we go inside, what happens to the gravity? Decreases. Can you tell me that when we go inside, why we should neglect this? There are particles of the earth. There are the particles of the earth. All these particles, are they not attracting it? They are attracting it. Then how can we cancel it? Why we say there will be no force and you say yes, there will be no force? Why? Pardon? One particle? Yes, that is an appropriate question. That is appropriate answer. What is that? You see, I divided into this way. This particle is attracted by all these particles on right side, all these particles on left side. They are equal, cancel. Okay. Now this particle is attracted by so many particles towards up and so many particles towards down. But that force is also equal. Why? Because these distances are more. These distances are very close by. So the distance makes a difference. The distance makes a difference. So if we calculate net force, the net force upward is equal to the net force downward, because their distance is more. Their distance is more, but their number is also more. So ultimately, sum of the two becomes equal. Downward equal upward. When we are doing calculus, by calculus, it has been proved. You can also prove it. It's a very small derivation that forces downward, forces upward are equal. So it is not that gravitational force because of all these particles is not working. It is working, but it is cancelling out. It is cancelling out. The same thing you study in Gauss theorem, in electrostatics. What we say, the charge inside the body is creating an electric field and electric flux. Why the charge outside is not creating electric flux? Answer, it does create. But what happens? Because it is outside, the flux on one surface and the flux on the opposite surface both cancel each other. Understand? But if the charge is inside the body, then all the electric field has this direction and there is no cancelling. So we get the flux only because of the charge which is inside. Outside gets cancelled. It is not that it is not making electric field or not making flux. It does make. It cancels out. Anyway, is this clear? A very small question in competitive examination. When we go to a certain height, y, we go to a certain depth, y, in both the cases, what will happen to acceleration due to gravity? Decrease. In which case it will decrease more? Height or inside? How can you say that? Give a proof. Only one person study in the class. Okay. The grading of reduction is given by this formula, d upon r. But in case of height, what was it? Yes, this is y, this is y. In which case reduction is more? Where it is 2, and that is height. So if we go the same distance up and the same distance down, in which case depletion is more height. So please note it down in one sentence. The depletion of G is more with height. This is the nutshell of it. Depletion of G is more with height. And you remember now how the question will come? If you go to the same height and same depth, in which case it will be more. Or the depletion is more with what? Like this. So any of the languages can be used, but now you understand it. Okay? So, but please remember the fundamental formula. The fundamental formula is this. Everything we do with this. Okay. So this was variation due to height and variation due to depth. Now we go to something else. The four things we studied. Now we go for decrease in the acceleration value due to rotation of the earth. Due to rotation. Why there should be decrease? The answer is due to centripetal or centrifugal forces. Third, to what you have studied, due to height, due to depth, and third is due to rotation. Because Earth is rotating about an axis. Earth is rotating about an axis. Where is the speed maximum on the surface? Where is the speed maximum on the surface? Earth takes 24 hours for one rotation. That everybody knows? In 24 hours, this particle makes this small circle, while this particle makes a large circle. 2 pi r here is small, 2 pi r here is very large. But this covers in 24 hours, this also covers in 24 hours. So which one has to run faster? At equator or at any other place? At equator. So where the particles have maximum v velocity? Equator. Okay. Where the particles have maximum angular velocity? Everywhere. Same. That is omega I am asking. Omega is how much? 360 degree divided by 24 hours. Right? Degree per hour. But linear velocity is different. What is the formula for centrifugal force? This V. This is which velocity? Linear velocity. That means the centrifugal force is always greater at the equator. This is the centripetal force which is pushing the object out from the earth. And why the object does not go out? Because the gravity is pulling it down. How much is that gravity? mg. Mass into acceleration of gravity. This is inside, this is outside. So what is the resultant? This is the resultant. If this is the resultant, then we can write it as m common this, that is all mathematics. Now with this resultant, if I drop an object here, it will go towards the earth. Is it going with a full force mg? No, it is going with this force. So if it is having an acceleration a, how can I calculate that force? That is m into a, and that is equal to this. Right? I don't understand that there is a force like this. What I say, it is falling under some force, and that acceleration is due to gravity. I misinterpret as acceleration due to gravity. So I don't write it G, I don't write it A, I will write it G dash. G dash means what it appears to me. So this mg dash is equal to this. Now cancel out m. So what do we get? G dash is equal to G minus V square upon R. Now can you convert this V into omega? V is equal to? Yes, so this will be? Right? 1 R is cancelled and we get it R omega square. Now it has become very better expression. Why? The velocity at every point keeps on changing. Omega does not change. I told you it remains same all over here. So this is a constant, this is a constant. So G dash depends only on radius of the earth. Understand? So this is the effect of rotation and it depends upon the radius. But this radius of rotation again depends upon something else. See, a particle is here. Then what is its radius of rotation? Is it equal to R or is it equal to R? Small r. What is this rotation? Radius of rotation of this particle when the earth is rotating. Which R? Close your eyes, imagine the earth is rotating. Where is the circle of this point? Is this circle like this or it is circle like this? This has got radius how much? Small. This has got radius. How this point is rotating? Think. You mean to say earth is rotating like this? This is the axis of rotation. Rotate the earth about this axis. Then what will be the radius of this? This way or this way? Yes, this will be smaller. So any particle is not rotating because of with this radius. It is rotating always with small r. And what is this small r? This small r is if this angle, this point, what is the location of this point? I tell you, how do I measure in geography? This is the plane which is having equator, equatorial plane. This is, what is this? A laddu or a fruit. Cut it at the center. That plane is known as equatorial plane. Right. Now this point join with the center. If it is here, this angle will be small. If this is here, the angle is larger. If it is here, the angle will be much larger. This angle, lambda, this angle and this r, it has a relation. If this is lambda, this is also lambda. This is r. So how much this r is equal to? Lambda. What is this lambda known as in geography? Yes, there are two lines on the earth. One are vertical lines and one are horizontal lines. What are those lines known as? Latitude and longitude. What are the horizontal lines? Latitude. This is latitude. You see, latitude here, angle is, this is latitude 90. This latitude, how much is the angle? This latitude is 0. This is 90. Go for 30 degree, this is latitude 30. Go for 60 degree, this is latitude 60. The best way to tell the angle. So latitude is decided by what? By an angle which that point makes at the center with the equatorial plane. That is how we decide latitude. Understand? Oh. Now this particle is rotating with this radius small r, this is capital R. Now can you tell me what should be the direction of centrifugal force at this point? Will it be in direction number 1, in direction number 2, in direction number 3, or in direction, any other direction, or tangential? 4. In which direction will be the centrifugal force for this? 1, 2, 3 or 4 centrifugal force. Again close your eyes. This is the axis. Rotate it. Circle. Which is the radius of that circle? Small r, capital R. Increase small r outward. Because centrifugal is always outward, radial outward. And what is that effective radius here? Small r. So what would be the direction of force? 3, yes. So this is like this. Here what we have? What is the direction of gravitation force of Earth? This. G is acting towards center of the Earth. I want to know what is the decrease in the G. Should I reduce mv square upon r from G? Can? No, I cannot. First, I must make components of it. Please see here. This angle is lambda. How much is this component? Cos lambda. Okay. So this force is mv square upon r into cos lambda. Now you tell me what is the effective force in this direction. mg dash is equal to mg minus cos lambda. This is equal to mg minus m. This is omega square cos lambda. This is equal to mg minus r omega square cos lambda. Now this r is equal to what? This is lambda. So this r is equal to capital R cos lambda. This cos lambda. Cos square lambda. This. Okay? Cancel out m. So what is the resultant acceleration due to gravity? G minus r omega square cos square lambda. G is constant, r is constant, omega is constant. So G dash depends upon what? Lambda. And the lambda keeps on changing. So this effect is because of what you call latitude. So this is known as latitude effect. What effect? Latitude effect on G. Understand? Because this is related to latitude. Now, this is minus, subtraction. When this whole thing will be 0? When this whole thing will be 0? When these two are equal to each other? Okay. If I want to make G dash equal to G, G dash equal to G, then this thing will be equal to 0. How this will be equal to 0? Lambda should be equal to 90 degree. Okay. At that time, how much will be the reduction? No reduction. So G does not reduce from its maximum value at which point? Where lambda is equal to 0, that is at poles. So please write at pole. At pole, lambda is equal to 90 degree, G dash is equal to G. This value is what? Maximum. and opposite to this, yes, at equator 0 degree. Now this will be 1. If you make it equal to 1, then G minus, yes, and this value is minimum. So due to rotation, single question, due to rotation, at which point G is minimum, at which point it is maximum? Minimum at the equator, maximum at the poles, due to rotation. And at any other point, it is given by this formula. So this 1, 2, 3, remember these 3 answers due to rotation. And what I think, only if you remember these 3 answers, your job is done. You don't have to go for this derivation. It was just to understand that it is related to lambda. So in the next revision, only remember these answers only. Okay, so based on this action, we will have many numericals to do. I have one numerical, we will practice it. Now, there is one more reason. 3 reasons of gravity variations we have done. Other is shape of the earth. Shape of the earth also contribute for variation. How it is? Can I rub it off?
Yes, sir.
This is a perfect circle, but due to its rotation and due to centrifugal force of the molten material, the earth has been reshaped. What has happened? There was always force this way, so earth shape has now become like this. This is the shape of the earth now. So this diameter has become smaller and this diameter has become larger. If this diameter is larger and this is smaller, then object on this surface and object at this surface have got different distance from the center. And what is the formula for G? Yes. In this case, what has happened? Minus h. In this case, what has happened? Plus h. So here gravity will be less and here it will be more. The same effect was there due to rotation. Same is the effect due to shape. So that's why gravity at the pole is maximum and gravity at the equator is minimum. So for gravity at equator, why it is minimum? Due to 2 reasons. One is rotation and other is shape of the earth. So these are variations due to gravity.